We appreciate you taking the time to join us for this conversation. This is a conversation I've been looking forward to for a couple weeks. I think when I first met our guest today, Norberto, I found somebody who can definitely shares a fair amount of passion for this topic for sure, which is databases in general. So I think this will be a great conversation today. But before we get started, just a couple of quick housekeeping stuff. Today is intermediate. People ask us, is it basic, is it advanced? We're going to be talking code, but we're definitely going to be talking deep into transactional models and distributed databases and some other stuff. We would love questions from you along the way. So please do use the chat or the QA panel. I'll be monitoring both along the way. Norberto and I both are very happy to take questions live as we're talking through things, and I'll work them into the conversation itself. And then the recording will definitely be available a little later today. I'm pretty much sure it actually is up on our YouTube channel fairly quickly. And so, but first of all, literally, thank you everybody for joining us. I know there's many of you who are now on the Zoom webinar here, but also those that join us on LinkedIn and in YouTube. Again, if you just filter your chat questions into those platforms, I'm pretty sure the team will work that in so that I can get those things as well. So I'm going to come on camera here. Norberto, you want to join me? Oh, I'm not on the thank you slide yet, man. I have such a nervous laptop. It just wants to actually, I don't know. You know what? I'm gonna stop sharing screen. I can't get the thing to come under control. I've been having a heck of a morning, Norberto. I am literally at y'all. I'm at Game Developer Conference here in San Francisco. So GDC happens every year. It's a live show again. There's actually people here, which is kind of cool. I just gave a talk and I'm just ran down the hallway to be here. But Norberto, thank you for joining us.
Absolutely, pleasure. Thank you for inviting me.
Yeah, you bet. I thank my friend Dan Kelly in many ways to reach out for you. So, y'all, my name is Jim. I am the principal product evangelist here at Cockroach Labs. My job here is to, talk about interesting things within the context of our product, and I'm really happy to explore Cockroach and how it works from any layer. Get into the deepest layers and deepest technical questions that you have. We're happy to talk through those. But I'm happy to talk through anything from a kind of functional or business level as well across what we're doing here. But our topic today is to really talk about the document model versus the relational model and some of those things. And I'm really excited to have Norberto here. So Norberto, you want to just give a quick introduction to yourself and what makes you an expert on this topic?
Sure thing. Well, calling me an expert in anything probably
yeah, right.
An overstatement on all regards, but my name is Norberto. I work for Okta. I'm a principal engineer on the storage layer at Okta. And I kind of know a little bit about document model databases because in previous life I worked for MongoDB as many different roles in many different facilities. But I did run for a while the education team. So let's say I know a little bit of that particular database more than others.
You would think after like 2 years of the pandemic, I would figure out the mute button. But you also are kind of, you're also kind of deep entrenched just in databases in general, right? I mean, you have kind of a little bit of a love of databases as well, right?
Absolutely. So if there's one thing that I really like to work on top of, I make work and break and make sure it actually meets desired scalability, performance, whatever, is databases. It's a very bad thing to have. A database typically the last thing you want to think of, or you typically don't want to deal with. But in my case, this is the thing that I like to break the most. So I do like to stress them out and see where they can go, because it's a really, really important aspect of any business these days is the data that the businesses hold, the information is the new oil, and therefore databases are a key functional aspect of any infrastructure for that matter.
Yeah. And I think the concept of a database actually seems pretty simple, right? You ask it things and it stores things, right? It answers, right? And it stores things. But I think in their implementation details, they're all extremely complex. I think if it was easy to build a database, we would build a database for every application.
Yeah.
It's simply not.
I mean, it is not easy to build a database, I can assure you that, but it's also not easy to run a database. It's typically not easy to, well, if things are done pretty well, it's much more easier to use a database than actually do all the stuff related with it. But yes, databases are complex beasts. If you think about the simplest use case that you can think of, which is I write something somewhere and then I try to get it back, that in itself, it's a very good, simple abstraction of all the things that a database can do. But it comes to mind that when you're building a database or when you're operating with a database, you need to think about all the other things around it. How do you store it? How do you distribute it? Where do you read it? What do you read? Do you read it when you ask for it on the same timestamp, or you wait for the next thing that is coming along to commit or to roll back? All of these things, concurrency level, distribution, transactionability, latency, availability, all of these things come to play and make this whole thing a little more complicated than just write something, get it back.
Yeah, security. I mean, I don't even want to open up that ball of wax, but I mean, it's a wholly other kind of level of chaos, right? And I think if it was easy to build databases, we would all be doing it. And I think it's, you said it very well, Roberto, and it's all the stuff around it, and it's the corner cases of all the things that can go wrong. Yep. Where I think people, that's where, it's funny. One of the founders here at Cockroach Labs, guy by the name of Ben Darnell. Ben, is one of the original 300 people at Google. Super amazing engineer. He said to me one day, he's like, Jim, I can build Raft in undergrad in under a day and have it working, but to do it in production, it's taken me 6.5 years to do it. Because it's right, it's all the weird stuff that can go wrong is some of those things. So, but we wanted to explore a little bit across, some of those challenges. And I think, Norberto, you and I were talking about this. This is a topic, and hey, y'all, if you want to go Google search, distributed versus relational, or document model versus relational model, go ahead. You're going to find what? A couple thousand blog posts, dude, right?
No, I mean, I don't know what the categorization was, but Google search gave me 140 billion results.
Yeah.
Just on that.
Okay. 140 billion.
So it's a very hot topic. It's definitely something that either a lot of people invest a lot of SEO on it, or there's a lot of interest about all of these things related with databases. Because at the end of the day, if you're building an application, you're definitely going to need to go through this at some point. Yeah. You need to decide which database you want to go for. You need to understand the different technologies around. So you probably are going to be interested in knowing what to shop around to make good decisions on.
Well, I kind of look at it as, well, there's a validity in the document model. There's right workloads and there's right use cases for both. And I think people are trying to figure out where to use which. I think there's a lot of marketers who are playing off of we're better. I don't think this is a conversation of what's better one way or the other today, y'all. And if it is, then y'all chat and let us know. Because I don't think that's not what we want to talk about. What we want to talk about is the challenges, kind of more of into one-to-one basis, right? So I think there's been a lot of advances, and I work at Cockroach Lab, so I live in a little bit of a different world from the traditional relational database. These are distributed systems. We like to think that we took a lot of the same kind of core concepts that are in something like a Mongo or a Dynamo or any one of these kind of large NoSQL databases, and now we're trying to apply that to transactions so that we kind of go back in time a little bit, right? Because I think we've advanced as software engineers, right, Roberto? There's been fundamental shifts in the way that we think about systems, correct?
Yeah, absolutely. Yeah. So if we think about the typical, now let's go back a few decades, it will be a mainframe where everyone just be connected by the same wires, and you'll punch some keyboards and everything will get into a very systematically controlled environment. Today, everyone has a smartphone or a fridge or a car or anything that can reach the internet and do something. It needs data. It needs to interact with all that stuff. So the paradigm shifted quite a lot. The technology evolved quite a lot. New, let's say, sound barriers have been crossed in terms of database development, and new models, new mechanisms to store, disperse, and retrieve information are required. It's not like one thing is better for another, it's probably one thing better suits the needs of a business or an application better than the other. So the good thing is that we have choice. And the good thing is that we need to understand where things get different. Why do we have so many different technologies for this? Well, typically same result, right? I write something, I get it back.
Right. And it's different requirements based on what you're trying to accomplish. Like, typically, I mean, I talk to people all the time. And I'm like, I think the pandemic would have been horrible if we didn't have Cassandra. Like literally, like if we think about the streaming services without Cassandra, we wouldn't have had all that, right? Like it's like, yeah, so there's the right place for the right tool. But I think there's always advances and there's new ways of doing things. And I think as we kind of hurdle towards this kind of distributed mindset as developers, yeah, there's a little bit different way of doing things now from the relational side. If I look back in time, it's like, yeah, look, Google, God bless them. They invent half of the stuff that we're actually living in now, right? Like, it's like, well, they had Bigtable. And that kind of started the new SQL movement a little bit, right? Like it was awesome and it's amazing. It's inspired a lot. They basically said, well, we need transactions and consistent data across the globe. And instead of basically using Bigtable or trying to retrofit it, they said, let's just restart. That's where Cockroach comes from, y'all. And this is inspired by something they did called Spanner. And so I think we're going to touch on some of those things that were the problems they saw that I think are kind of playing out today, right? So
and typically, if you think about it from an engineering perspective, it's all about constraints. So you will adjust the tools that you have to the constraints that you have. If your model changes quite a lot, if you now have a web app and it's not all in the centralized under the same building kind of application that needs to run, you probably have a different set of constraints that you used to have. So adjusting to that and setting up for the right tool for your problem, it's probably where you want to go for.
Yeah. So first of all, also, y'all, I'm again sorry if there's some background noise. I don't know how much you're picking that up or not, Norberto, but again, I'm at a conference. Yeah, it's just, of course, when you start talking, people like stand like 5 feet away. So that's just it's Murphy's law. What can go wrong will. By the way, what can go wrong will for all your code. So, so let's talk about. I think the first difference I would love to explore with you is, the transactional model and what does it mean to be a transaction within a database, right? And I think when you start to look at the document model versus the relational model, I think this is the biggest kind of disparity or the largest difference. Would you agree, Norberto?
In a certain way, yeah. So when we're talking about documents, we are mostly focused on a few basic rules of how do we model things. Typically, you go from usage. What kind of data structures you use together, what kind of things make shift, let's say, or define a particular attribute or particular subject that you want to model into data. And typically in a relational model, you would go for the 6 normal form until you get it right, and then you start denormalizing until you get it to work. From the document model, it's all about usage. What things I use together should go together. What things define an attribute, define a subject, define an object should go together and should be stored in that way. Now, that brings a lot of problems like data duplication and consistency and a bunch of other things that you need to be aware of, and you need to know what you'll deal with. So typically, the availability of data and consistency are things that come along. You want to make sure that your data is available, and you don't want to do like 50 different queries or a big join to get all those things from when you're using a document model. Why? Those are costly, and probably the database has not been thought for that. What has been thought for is that your data will sit together in a nice shaped document that reflects how you use it. From a data consistency perspective, you also have, if you have to write 3 different documents or 3 different data structures to store your information, well, you will need to go into a transactional mode. Some databases, like MongoDB, they now support that, but that's a new thing. And it works. It has its constraints associated with it. And you should try to avoid it if you are thinking about using a document model to begin with. Atomic writes, it's the best transactional model you can find. And what does that mean? If everything sits in the same document, it's always going to be atomic, it's always going to be consistent, and it's always going to be available in that regard. It might be challenging in some cases to get different shapes, and you need to think about how the data is being used altogether because you don't want to blot a lot of the data inside of a single document. There's constraints about that as well. But at the essence, you should think about from it, what kind of data needs to go together? What kind of life cycle does your data attributes need to obey for? If they have the same write patterns, if they have the same access patterns to it, then probably it's a good fit to get them all together. And all the problems in terms of availability consistency are reduced to the atomicity of a document. In relational, it's not exactly like that. You distribute it a little bit more, but it has that advantage of making sure that you don't have any data duplication, and you are aware that your transaction will take care of all the consistency for you.
Yeah, I think that's such a great way of looking at it. It's like, yeah, the document model, it is really literally about usage. I think that's why people like the document model. It's like, okay, that looks like the object that I want to model, and that's everything. I don't have to go to 4 tables to construct, the person object or whatever that is. Like, it's kind of more of a one-to-one mapping, and you may know what all that is, but there's some significant power on the relational side. Honestly, dude, I'm sorry, I'll out myself. I learned kind of on the relational side. I think I gave up on the document model somewhere around XML, I think. But it's, for me, it's like, I thought normalization, I thought in referential integrity, I thought in terms of joins, I thought in terms of materialized views. Like, there's power in the calculus that sits behind the relational model, which I don't think people really truly grok, right? Like, it's actually derived out of, like, literally math, right? The relational model, right? Whereas, like, the other side, it's more like this. It's flat out usage, right? How do you choose? Go ahead, please.
No, I was going to say that's exactly the genesis. I would say that a lot of the NoSQL movement was, you not always want to have this highly precise data structure to reflect every single business use case that you have under the sun. You don't need that. Most of the cases, some of the data is completely discarded, or some data is only needed for a particular set of usage that not necessarily needs to be kept along for a long time, or it will infer data, but you're probably going to have multiple copies of that along the way, and you just want to keep the snapshots of those. So if you invest a lot in a data model that is super, super correct and super precise, you're probably going to be not focusing on the usability and getting those iteration cycles that you probably need for a fast-paced application development methodology that we typically have. And one of the things that drives people to document models, it's the unavailability of alter tables. That is what kills most folks, because if I had the data in certain shape back in the day, a document model allows me to keep iterating without modifying that if needed, which has a lot of agility to it. It allows you to increment faster and do it develop faster. Jim, I think you're muted.
Oh, I'm still here. Sorry, I thought I lost you for a second.
Oh no!
I'm on conference. I'm on conference Wi-Fi. Sorry, buddy. Like, I thought I lost you for a second. You yeah. Well, for me, Norberto, when you have to choose between document model and relational model, like, it's just, you're a developer making that choice. I think a lot of us choose on what we're familiar with. God, then they teach the document model in college these days. It's great, like, where's the relational SQL courses, right? Like, and I think, like I said, I would use what I'm used to. How do you think about it from a workload point of view, what you're going to use? Yeah. Like, what are the characteristics? Like, we talk all day long calculus versus like usage, but like, what practically?
Well, practically for me is the way I like to conceive this is that documents for me are multidimensional data structures. What does that mean? If I need to reference something which has a variety of different attributes that can vary widely between different objects, let's say, for example, in a house, there are particular things about the house that are always there, like, I don't know, an address, a number of rooms, bathrooms, square footage, all that stuff. That is easily modeled either in a document or a relational model. That's fine. But then there are certain attributes that make a house different. Like, does it have dual vanities on the bathrooms? Yeah, you can model that, but you're getting into the specificity, which is probably not going to gel well with every single one of them. Does it have views to the skyline or the lake? a lot of different things, a lot of different attributes that define the objects that you are trying to model may vary widely between them. And if you want to capture all that in a relational model, you're probably going to have a very complex model. Works, probably not as fast, probably super fast, doesn't matter, but the pace by which you can apply modifications to it might cripple you a little bit. If that's the case, then the document model kind of fits very well. It's flexible enough for you to adjust to incremental changes, but it also is encompassed in itself that you have all the attributes that you want, and you can actually grow it with not affecting the structure of the rest of the records that you have in your database. That's one of the biggest advantages I have. If you don't have that need, then the relational model probably going to be working for you way better. It all depends on, as you said, what kind of skills you have in terms of on top of database that you're developing, and if that model actually helps you or sets you back a little bit.
Yeah, and I think the traditional relational model, that's definitely the case. I think doing things, making changes in production and making sure that, like, if you are going to change schema and you are going to change some sort of structure or add some sort of component, like, okay, great, you have bathrooms, but you also want to model, like, I don't know, sunrooms, or I don't know, pools in the backyard. Adding those with a very different kind of attributes. Yeah, sure, you guys could just add it within the document model. But if you need to change things and, like, you have any sort of reference between objects, well, that's where things get really complicated, right? Because you need, what's the data correctness here, right? And that's where things get really, really tricky.
And that's a trade-off, right? If you want to model all those things together, you need to model them probably most cases in an atomic way, everything under a single document. And that might come with trade-offs in the future, like if the documents get overloaded or with lots of different hierarchies to it, if they are very complex to handle it, to iterate. So you need to balance these things together to make sure that you understand what the business needs are and how you get there faster.
Yeah, let's talk about bloat as well, Norberto, because I think this is another one of those areas where, like, for me, I can only consume so much. Again, I love the relational model because it breaks things down into the constituent, like the components that I think about. Like I think about a customer as X, Y, and Z, but I think about an address as a separate object. Like, I don't want 15 addresses. And what happens when there's like 30 associated with somebody, and my document model gets, I don't want to parse and deal with all this craziness, right? Like, I love the calculus and the simplicity, the elegance, I guess, of the relational model in many ways. Where do you come to limits with the document model in terms of, like, how complex is it? Number of documents? Is it size of document? Because I think that's also a challenge for people, right?
Yes, there are a few things that you need to be careful about when you design your documents. One of them is unbounded arrays. The example that you are giving is a typical one. Like, most people have maybe one address, maybe two if they consider their parents' addresses. But some folks are real estate developers. They have, I don't know, gazillions of those. How do you make sure that you don't let the outliers of your user base overload you quite a lot? A typical example for this is like the number of followers of Twitter. Yes, the majority of us is probably going to have a few acquaintances and some other folks following each other. But then you have like Cristiano Ronaldo or some other famous person that has millions and millions
Michael
of followers.
Jordan.
Right?
I like Michael Jordan a little better, but yeah.
For sure. I'm pulling the strings from my own country.
I know.
But the problem there comes when you do have these unbounded relationships that in the relational model, it's not a problem at all. It's just another fetch of XYZ, of X cardinality. While in the document, you will reach the limits of the documents if you don't care too much about that. So what you typically have to do is put business logic, your code, to work there. And you probably need to use some patterns. I have a good friend of mine, Daniel Kopal, which wrote a bunch of different patterns for document modeling. And one of them that would apply here would be the outlier, where you actually define a maximum number of, for example, addresses for a house, and everything else would go to an extra document. Next time you do a fetch, you don't go to the same document, you go to an extended one, and there's links between them. Now, making sure that those links work, making sure that the relational integrity works, there's none. There's no way that you can guarantee on an MongoDB database, for example, or the typical document model. It definitely is there. It's part of the core foundations of the relational system. So that's the big benefit. But if you can live with it, and if they are outliers, then you don't have a problem. So you think about you taking care about the 80% of use cases or the 90% of use cases, and you adjust for the 10% or 1%, depending on what variation do you have. The cardinality of the relationships is really, really important when you're thinking about the document.
Well, yeah, and if we think about relational databases, you start thinking about cardinality of queries and how you're designing it. And basically, you don't want to do table scans because that doesn't make a whole lot of sense. And so, to me, being able to design against that to performance tune and use the relational model to do so is very powerful. And it really comes down to like, what do you want to solve? Right? Like, I mean, the question shouldn't be like, is one better than the other? It's more like, what do you want to solve for? And when I think about usage, I think of like a lot of these kind of like, I think about like more like the closer you're getting to like display, and the closer you're getting to like pure consumption as opposed to the transactional side. And to me, transactions, they should be correct. They should be, I don't think people actually understand what isolation levels are, by the way. I think if we ask 10 developers, how many do you think would actually know what isolation levels were in a database? I don't know. What's your gut, Norberto?
I mean, maybe 10% will know because they will be
Exactly,
using
right.
databases on their daily basis, and they will kind of have
Right.
any hints of what that means. At the bottom line, I think that's one of the typical paths folks go through is if they need to iterate faster, if they don't really know what the shape of documents or shape of their data structures are looking like, a document model is a very good first approach.
Yep.
If they need to scale and all of that, can get into that discussion a little bit later. But once you settle for a very good model that doesn't change, and if you are hitting some performance issues, and if the relational model better adjusts that, then typically what people do is move. We at Okta have recently been doing some of that, where we looked into our data model for the last 80 years or so. We were using only one database, which was MongoDB, but then we started making efficient decisions and saying, okay, this data is purely relational. There's no need for it to be on a document database. So let's move it to a relational database. And that's fine. That is actually a good decision to do because it will help you make sure you are picking the right tools for the problems you're trying to solve.
And honestly, I think there's been a lot of advances for you to actually change models in production live, like for CockroachDB and other distributed databases, some do this online schema changes because the way that we actually deal with data is we're writing in a triplicate and we can actually have two models actually living at once. And so I think there's been a lot of changes, and I think the way that distributed systems works allows us to do a lot more of that kind of activity as well, Roberto. So I think it's getting interesting to see where do these things overlap, and where do you choose one versus the other? But we talked a little bit about, so there's a question about transactions, and I'll use that question to kind of frame the next part of our conversation, right? There's this myth, right? If transactions are involved, go to relational. But if it's high scale and performance where you're getting data, out to lots of people, that sort of stuff, you'd use NoSQL. What do you think about that as just a general statement? Transactions are for relational, whereas kind of other uses are NoSQL. How do you feel about that?
Well, I think about it in this term. Like MongoDB supports now transactions, so that's typically used to be an objection that everyone would have about using something like MongoDB or something like NoSQL. And yes, that's true. It didn't used to exist, or probably is not as well shaped like some other databases that have that cord into their foundational part. But that's not really the point when you are dealing with document models. If you have atomic operations on top of your documents, meaning that everything single write that you need to do is within a single document, you do not need transactions. Typically, transactions only are there if you want to test something and roll it back immediately. That's the same thing as an insert and a delete or an insert and an upsert. There are more nuances to this. If you are only partially updating a document and you want to roll it all back and all that stuff, then a transaction may come in handy. But that's super fast anyway, because it is all inside of a single particular node and handled by what MongoDB calls a primary node. Once we are in a distributed world, then things get a little bit more complicated. And only with a recent version of 4.4 that MongoDB allowed you to do cross-shard transactions. And what does that mean? It means that a particular operation that is happening on one or more documents needs to be confirmed by more than one node. That implies coordination, that implies latency, that implies longer times to wait. That is all fine if your business requirements allow it. Because if you really need to wait for all the nodes to be compliant back and coordinated and say, okay, we have all the rights that you want to confirm, now you can commit, well, great. If not, you're probably going to need to have some other tool that allows you to do that same. I probably like Cockroach. I can't say I'm really that familiar with the transactional model of Cockroach right now because it evolved quite a lot since the last time I used it. But typically, it will allow you to do that based on some sort of mechanism that stops time or makes sure the time is always the same across every single node, which is really, really hard, and allows you to achieve that in a seamless way. So transactions typically are not needed. If they are needed, for sure, a relational system is probably better suited. But in essence, if you look really deep, your transaction can be modeled into a document. If not, well, then you're going to need to, it's going to be taking a lot longer to get your right confirmed.
Yeah, and typically on the relational side, for us, basically it comes down to the complexity of what you're trying to accomplish. Like you said, if it's all in one single document, and it's atomic and it's in a single region or on a single server, great, go for it. I think that's pretty simple and straightforward. It's the minute you start getting across different documents, across different objects, and coalescing these sort of things. I mean, it's why databases, were very complex in the very beginning. I mean, how do you lock tables and how do you avoid table scans and all these different things? And so I think there's been so many advances in distributed systems and really in database side that actually allows you to do this very elegantly. Do this with, across multiple regions. And, being able to fight latency is no joke, dude. You cannot fight the speed of light. If somebody can help me, if somebody tell me how to beat the speed of light, great. I have 15 startups for you right now. You know what I mean? And that's a problem. So when you start to look at, cross document, cross shards, cross objects in a relational database, and you do that at scale across, not just in a single region, across, let's just say multiple different AZs, let alone multiple regions or the globe. These are not simple software engineering problems to solve. They've been solved though. And I think that's what's interesting right now. Yeah. And
we have a solution for it. But I think that the biggest issue with this is that whatever it takes for a transaction to complete across the distributed node, you need to think about it in time, which means I think there's a quote attributed to Einstein that said that if there's only one clock in the world, there's no problem. If there's two, you're screwed. You're never going to know exactly what time it is. And that happens exactly in the same way in terms of database nodes. You always need a third node to tell you, you two are fighting, but we're going to settle on X. And typically that's how we do things in terms of either a transactional model or even in a multi-master active-active kind of technology where there needs to be some consensus about who is the right commit to be going through. But going back into this notion of transactions, the unit of time that happens on the node at that point in time, the write-ahead log or the way that we have to conflict or convey different versions, the MVCC model, that is the most elegant solution that came up in the recent years. And that's what the basis of a lot of these, I think Cockroach as well, a lot of these models that allow you to do transactional distributed commits across multiple different nodes in different database technologies.
And I think that's exactly kind of the point. It's there's been significant advances in software engineering that allow us to do these things efficiently and effectively in the right time as well, right? And I think that's kind of the thing. If anybody's listening, they don't understand Raft or Paxos yet, I would go check it out, right? It's distributed consensus. And part of what Norberto was talking about was when I write records to a distributed system, I need to get quorum, basically, quorum commitment on whatever that record is. And that's really a big part of the transactional model in a distributed relational database. And you're saying, look at I'm going to replicate data 3 times within a cluster, or 5, or 7, or 9, some odd number. And you need to get 3 out of, you need to get 2 out of 3, or you need 3 out of 5, right? And so you're going to be
you need a majority.
Right.
Yeah.
You need a majority, like you need quorum, and that concept within distributed systems is a big deal, right? And then, but it doesn't end there. There's also Roberto actually just spoke about it, MVCC, which is multi-version concurrency control, which basically says, look, if we all have the same time, like Roberto, your clock on your wall says the exact same time that I have, and this is the exact problem with time in these distributed systems, then we're going to be okay, because I can say, hey, look, I committed at this time. You're going to commit at this time. We could look at timestamps about who cross reads and writes and when things happen. And if something comes in between the middle of a read and a write, there's all these huge, crazy complexities. Actually, the Wikipedia article on MVCC does a pretty damn good job. Whoever wrote that, kudos to them. It does a really good job. And so basically, it's basically saying, like, look, it's like a teller at a store. Whoever came in order, those are the way those transactions are going to actually be implemented. And within the concept of a distributed relational database, that's a key concept, because making sure that transactions are correct, fit certain workloads. There's a concept of consistent and serializable isolation, which is again one of these. Remember, I don't know literally how many people really understand isolation levels. Guaranteeing data is correct in the database is very different than it, avoiding some of the write issues that can happen, like a phantom read or a dirty read or non-repeatable read. There's like lots of different things. And so, there's this concept of eventual consistency, Roberto. And I think, people read it and they're like, okay, how do you explain eventual consistency to somebody?
Well, eventual consistency is something that happened in the past. Or better saying, there is an order of operations that happen in the database. And if you're reading always in the case of MongoDB, from a system that privileges consistency, you always need to read it from the primary node, the node that accepts all reads and writes. However, it also allows you to read from secondary nodes. And what do secondary nodes have? The exact same data if they're in sync, but in contrast to a lot of different systems, I don't know about Cockroach, how we assure consistency across different nodes. In MongoDB, it's an asynchronous consistency model, which means that it's the responsibility of the secondary nodes to pull the data and to be in sync with the primary node. So if you are reading from the secondary nodes, you might have the chance of reading data that is not really the latest copy of that same document or records that you are looking at. So eventual consistency allows you to basically get a view of the data that has been replicated to a secondary node at some point in time.
Yeah. So for us, we err on the side of serializable. So data is going to be guaranteed correct no matter where you read it. In fact, we allow people to do something. You can relax that a little bit. You can say, hey, I can have, I can read from a follower read, we call that, like we're reading from we can allow that to happen. It really depends on what you're trying to accomplish with that particular table. And it's really at a table by table basis. It really comes down to the query and thinking through, like, okay, great. Is it okay if there's some sort of relaxed consistency here or not, right? If it's, account details at a bank, forget about it. If it's inventory and say a game and you have, two gamers fighting over the same NFT or whatever, a robe or whatever that is, that's a problem, right? And it really comes down to the workload and what you're trying to accomplish and really thinking through, like, what are the requirements around consistency? Because something like a Cockroach will guarantee your guarantee. And we made that decision very early on, because I think we're fighting two problems here. Not just the consistency of data, but doing that at scale across the world. When you have, a transaction can take, 250 milliseconds between, say, New York and Sydney, that you can't wait too long either, right? And so I think that's one of those things that not everybody really thinks about, but there's definitely differences between the types of database when you start thinking about those sort of things.
Yep. And just to add to that, that consistency guarantee exists in MongoDB no matter what. You just need to understand that there's certain things about the default. The default is very permissive in MongoDB. It allows you to read fast and write fast and all that stuff, contrary to probably what Cockroach does, which is ensures always consistency, always guarantees across all the nodes in the database. MongoDB, you can also get that, but you need to change the defaults, meaning that you need to apply a different write concern or a different read concern, saying, I always want to read data that has been majority committed, or it's been committed on all the nodes, for example. And that gives you the extra guarantees of consistency that you want. We probably errs on the side of making it faster and more available, and then probably having a little bit of eventual consistency by default, but it can always tune it back and say, no, I don't want that. I really want the data to be as accurate as possible.
Right. And I think like with any of these things, the CAP theorem is also one of these key concepts that people should be familiar with. Cockroach is a CP database, whereas Mongo is an AP database. It doesn't mean that Mongo is just AP. It means they can do some consistency of transactions. That's a range, right? It doesn't mean that Cockroach is only consistent. It's also hugely available. We can get to 5 nines availability if we want to. It depends on how much you tune and configure. And that's what I think that's actually a really important point, right, Norberto?
Yeah, no, absolutely. So it is important to understand all the CAP theorem and what it guarantees and what doesn't guarantee, what availability you have. It's also hard sometimes when you have so many, knobs that you can turn to adjust your database to what you want to do to qualify it exactly. You can even have the same conversation about some of the more traditional systems like Postgres, for example. It definitely is a CP, right? But it can also become a CA if you start reading from readers, or if you're using something like Aurora. It becomes a little bit more complicated to qualify these days because all of these technologies have evolved, so you can adjust to the read needs that the applications require. But in essence, you can only have one of those two combinations: partition tolerance, consistency, and availability. So you have to pick two. It doesn't need to be always the same thing, or it's hard to qualify these days a particular database on only a pair. It's typically two or more.
Yeah, and I think it's
typically two, actually.
Yeah, the ability to tune whatever it is that you're actually looking to do is actually pretty important. So it's all about how easy it is to do that, right? So
correct.
And how can you actually tune latencies across regions is it's not a simple thing to do. So when I start to look at like how databases do commits of transactions in distributed environments, latency is no joke. Like, we can't beat the speed of light. We talked about that a little bit before, right? And I think that's just one of those challenges that let the database deal with that. That's the way we think about it here at Cockroach. Let's let the database deal with the latency issues. And so for us, let's build something that's going to be guaranteed consistent, but give you all the tools in the world if you want to actually tune latency out of those performance characteristics as well. It's a big deal.
Yep.
So let's talk a little bit. I want to shift a little bit into, one of the other topics we want to talk about is data sovereignty. And I think, we, here at Cockroach, we actually designed a feature called geo-partitioning, which allows us to basically tie data to particular servers across broad geographic regions because, we wanted to fight latency. Honestly, like we want data to be close to users so that, and let the database deal with all of that. But we start to see this used for things like data sovereignty, where I want, certain data living in certain geographic regions because of, the jurisdictional, rules or whatever, there's data privacy concerns. Yeah. How do you think about that in a NoSQL world? I mean, do you have those controls?
Yes, you do. So in the case of MongoDB, it's very similar to what Cockroach does, which basically allows you to create a shard zone. And then what is a shard zone? It's basically a rule on top of, and now we're getting to another subject, which is called the shard key. A shard key is basically the rule by which you distribute data across different shards. Shards are replica sets that can be located on different geographies, locations, whatever you want. It's the unit of distribution. So once you write into a sharded collection, data is going to be distributed across those different shards. How you distribute it, is based on the shard key that you select. And if your shard key contains the geo identifier of your data, you can define zones or shard zones and tag them and say, okay, on shard 1 lives in Germany, and shard 2 lives in Hawaii, and shard 3 lives in South America. All the same database, but every time you read and write, you're always going to be hitting the same shards that contain that data that is geo-referenced. So you can easily just distribute it there and comply with the data sovereignty regulation, for example. Typically, that's what you do for that. And I think that's a little bit how Cockroach also does it, right?
Well, it is very similar, although, I think the value of the relational model comes in very well here because we're guaranteed that basically any of these keys is going to be of a certain set of values, like the whole referential integrity into that. Making sure that you don't have these kind of orphans, you don't know where they go, that sort of thing actually gets pretty important, especially if you're kind of dealing with these jurisdictional values. And so for us, we just feel the the guaranteed correctness allows us to do this in a way that's fairly efficient, and then basically making it very easy. You know, I don't want to think about a shard key or like a, and so for us, it's basically, you know, it's like choose a column on a table and we will change and we will move data around based on that. And all the other objects that are related to that, we will do that as well, right? It's not like each big, huge document. It's like, okay, great. And so really on a table by table basis, we can control that within Cockroach, right? And so it's down to the row level. And so you choose like some tables you want everywhere and you want fast access to that, you know, like discount codes for everybody across the whole planet. I need a copy everywhere, you know? But if it's, you know, customer address information, well, that stuff's got to live, you know, German stuff's got to live in Germany, you know, so like being able to configure that on a table by table basis and giving, you know, kind of these granular controls, I think, you know, for us is one of those things. It's one of those things that I saw in Cockroach I just couldn't unsee. It was really beautiful.
And just to be clear, the same shard key is defined on a collection by collection, so it's really similar to what Cockroach does. But you did mention a point which is typically hard, which is picking up a good shard key requires you to know very well your data model and how data is getting access and how data is going to be distributed. So yes, you're absolutely right. It's something that you need to put a lot of effort as a developer and in trying to figure it out.
You know, for us, it's like, and how do you add a new region? Well, we just change at the table. We have some simple DDL, and basically it starts moving data around. It's like simple one line command. And so I think those are some of the things that gets really interesting. So, so we I think hit on most of our topics. You know, what's, you know, so Norberto, if you think about like, what's the practical advice you would give to somebody who's thinking, you know, document versus relational, that sort of thing? Like what's kind of like the going away kind of advice you would give to people?
Yeah. So I have 5 takeaways, very generic in terms of database. There's a very good speaker that I know, Charity Majors. She typically says that the database you hate the most is the database you use the most. So make sure you hate your database quite a lot. It means that you're using it quite a lot. You know how to bend it. You know, you get to know the rules of the game, and you know how to use it quite well. When you get into the land of documents, things are driven by usage, not storage, typically. So it's something that you need to think of in terms of development model. Memory is abundant, but use it wisely. One of the things that document relational systems also use today quite a lot in Cockroach and MongoDB and a bunch of new technology in terms of databases, they heavily use memory, which is good, but make sure that you think about the scalability of that and make sure that even though it's abundant, you need to think very wisely about it. And at scale, the shape of your documents can be highly influenced by small variations in cardinality, as we talked about a little bit before. Unbounded arrays, things that go out of hand in terms of depth of the documents and so on. Those are things that you need to think of if you are dealing with a large scale system or a large scale database. And as for last, once you're distributed, you're not in Kansas anymore. That means that your data will effectively be flying across different nodes. In data partitioning, what does that mean? Well, the data center can go down and you still need to access your data, or you need to be sure that once you're writing that those writes are going to be confirmed and they're going to be there in multiple copies of your data. So all of these things have to be considered. And if you think about it in that way, a distributed database is like being in a never-ending Zoom call with your friends. Things might come out of order, and it's up to you to make sense of a little bit of the information flow. So there is a lot of responsibility, at least from when you're dealing with it from your application, that some things might not be as fast as you probably think they should be because you tested it on your laptop. They will probably hit the bounds of latency, and you need to be prepared for it.
Yeah, and I think that kind of lends to a lot of stuff that I think about too. You know, we used to think about the logical model of data, and I think in this distributed cloud-based world, Norberto, you have to think about the physical layer. You have to think about where data lives. It's actually pretty damn important because you're not in Kansas anymore. You're in a different world, and developing this distributed mindset about your data and actually thinking about those things, I think is like probably the most important thing to me, the paradigm to distributed systems was all about that. like really thinking physically about where things live and how my data works. I think that's the kind of right thing. And so, you know, it's, you know, to me, I'm sorry, but I disagree with you. You shouldn't hate your database. You should love your database. I think your database, I mean, I think it's true. I think if you use the right tool, you're going to like it because it provides the power you need to do what you want to accomplish.
Absolutely.
I don't think you should,
I don't disagree
ever
with that.
hate. I mean, yeah. And I think it's like, use what you're comfortable
but
with.
you're not getting frustrated with your database. It means you're not using it a lot. I mean, I hate a lot of things about MongoDB, but I love using it. I hate a lot of things about Postgres, but I love using it. For example, I do like a lot Coach Cockroach CD, probably because I don't use it too much. So you definitely need to start using Quilla.
We invite you to use it. In fact, you know, look at Spencer, the CEO of Cockroach, and I have these conversations, and you know, for us, why are we even dealing with databases, dude? Why are we even having this conversation? Literally, like to me, a database should be consolidated and just kind of simplified down to a SQL API in the cloud, some REST interface that I just code against, and I can change models. I can do whatever I want. It's going to guarantee the data is correct. It's going to guarantee it's available all over the planet, and it's going to be guaranteed consistent. And so great, if I have, you know, 7 endpoints across the planet, I have a serverless database, it's scaling up and down, only charging for what I use. That's what we're building. Like for us, like that's the goal. Right?
I guess that's the very good winning part for the developer. But if you need to run it, you're probably gonna.
Yeah, but that's the whole point. Why run it? You know what I mean?
It's
like why run
absolutely
it?
True.
Let's take that out of let's take that off the table. The database. Look at we have advanced as software engineers to basically take care of those sort of things. Like there's no longer you don't need to shard a Postgres anymore. Like use Cockroach. Like don't deal with any of that, right? Like it's going to guarantee your data is correct. That sort of stuff. Like this. The concept of resilience and having active passive systems and like, oh my God, the amount of people and time we spend dealing with this, like just use active. There's new databases that are out there. And so I think, you know, when I really start to think about this conversation between these things, I think about a couple different things. Number one, you know, you have to think about the physical versus logical. I think that's actually pretty damn important when you're thinking about data in modern cloud and modern architectures. I think it's pretty important. I also think the complexity of the model, what you actually want to do, you know, Norbert and I talked a little bit about kind of like the usage versus kind of like the functional side of things in terms of what you're doing with the data. I think it's actually a really, really big piece because if you have, you know, some backend services that are dealing with this kind of huge maximum document model, it's going to get complex for you. So, you know, the elegance of the relational model fits within certain concepts of whatever the app stack that you're building. You know, I think like purely like the document model works in many ways for a lot of like front end and certain things. It works in the back end too, but I think it's like choosing the right tools for what you want to do. And you kind of talk to that as well, right, Norberto? I think it's a big piece of this whole conversation for sure. So, yeah. Well, cool, dude. So I know you want to love your database too. I'm sorry, buddy. I had to go there.
No, absolutely.
Dude, I love this database.
It's a love-hate situation, which is fine. It's yeah.
Yeah, I just think it should just be more love than hate.
For sure.
You know, it should be more love than hate. You know, use what you're familiar with, but you know, be open to other things and different ways of doing things because there's power in these things. There's reasons why people use them. There's reasons why they're built. There's
I guess that's my mental model is if something makes me suffer, I'll bend it better and I'll learn it better and I'll learn to love it.
That's right.
It's like it's like starting to walk, right? You're gonna fall a lot of times, but once you do, you're done. You know.
It's funny, dude. You know, so a couple of years ago, I landed at I was kind of early days at CoreOS, right? And CoreOS is kind of driving the whole Kubernetes thing, and it was my first kind of real like. I was being thrown into the deep end of the pool on distributed systems. And it took me a while, dude. And it was like, it was painful to really kind of grok and understand, okay, great. It was a paradigm shift. It was a complete, total different mindset. And it hurt. But I tell you what, I came out the other end and it's great. I think it's like so powerful. It's like one of these things, once you see it, you can't unsee it. And I think that's
and if it's not challenging, right? If it's not challenging, it's not worth it.
Yeah. So. Well, cool. Actually, there was one question. So if query patterns are known, is NoSQL a good choice? Relational databases are good if query patterns are unknown. Because the question is like, I guess, is your query pattern and knowing it or not kind of one of these deciding factors on which database to use. How do you feel about that? Uh-oh. Did I lose Norberto, or did y'all lose me?
Uh-oh. I'm still here.
Yeah. You're still there. Okay,
cool.
good. I thought it was me.
I was going to say that query patterns, if we are thinking about it from, if you are very well defined, that doesn't mean that your usage is not going to be flexible and not going to be variable. So it is important that you know your query patterns no matter what database you use, because you need to have the right indexes in place. You need to have the right set of operations in place. So that is extremely important no matter what the database that you're using. So it's both valid for both. So the relation databases are good if the query patterns are unknown. Arbitrary queries are possible. So if your data is small, you're fine. If your data is really large and it's distributed, then you're probably going to have a problem. So be mindful of that.
Careful of the concept in distributed systems, and you may want to look hot ranges, and never do a table scan in a distributed environment. Right. So think about look up the concept of cardinality of a query, and if you don't know what cardinality of a query is, go read about it, because actually, I think it helps everybody design the way they think about their data a lot better as well. Number two, if you start to really think about that, like it's a very helpful concept.
Yeah.
I don't know how much they teach that in school anymore, but
yeah,
it was always a bit, normalization and cardinality were one of those things I always thought about. You start, crazy normal form, and you abstract down into what's right. So on the relational side, and I think that helps. So
absolutely.
Well, cool. Norberto, seriously, thank you for doing this with me. It's been fun talking through this whole thing, getting to know you a bit too as well. And I thoroughly enjoyed our conversation. I think we can both love databases. We can both hate them.
I promise next time I'll say I'm going to love my database quite a lot.
I know,
you have converted, my friend.
So, my friend, obrigado.
All right. Thanks, Jim.
Okay.
Have a good one.
All right. Thanks, everybody.
Bye, everyone.
Have a good day.